to the Growing Manchester Fermentation webinar. I'm John Ross from a social enterprise in Manchester called Sow the City. This webinar is part of a programme we run called Growing Manchester, which is funded by the NHS here in Manchester to improve access to sustainable food. I'm delighted to see that we've got people attending from Manchester, but also as far away as the Philippines, I think. So welcome to those people and thanks for coming along to everybody. Today, the presenter is Jonathon Curry, and he's going to talk for about 40 minutes about fermenting foods. It's a great way to store gluts of harvested produce, and there's some interesting new research about the benefits to health of fermentation to your gut biome. And I am going to take questions as we go along. So if you want to use the chat box in the bottom left of your screen, you can ask questions and Jonathon will answer those at the end of the webinar. Another thing to know about the system, if you've not used it before, at the top right of your screen, there's 4 little arrows that are pointing away from each other. If you press that button, then you can get a full screen view of the presentation as it goes along. If you do that, then you're going to need to sort of click back to be able to ask any questions, but it's quite helpful to do that, I think, sometimes. Okay, so I think that's it. Over to you, Jonathon.
All right, cheers, John. Hi, everyone. Yeah, so my name's Jonathon, and I'm just going to take us through the fermentation webinar today. So fermentation is something that I've been playing around with now in various different ways for sort of a couple of years. And I just thought I'd share some of like my experiences and the kinds of things like people can get into when they're starting fermentation. So here's a quick look at what we'll cover in today's webinar. So I'll take us through a quick introduction to fermentation. We'll take a look at the different microbes involved. My background is sort of microbiology, so I could rattle on for ages about this, but I'll keep it all simple. We'll take a look at the fermentation and health question and see where sort of the research is at the moment. We'll cover briefly the equipment and some basic concepts that you sort of need to understand. It's sort of different to traditional cooking in a way. So, you know, there's certain concepts that sort of apply across everything. So we'll cover some of them. We'll look at the fermentation types. So there's a huge variety of different types of ferment, but I've sort of focused in on a few that I use quite a lot around the house. So, well, mostly in the kitchen, not around the house. But yeah, so sauerkraut and kimchi. We'll look at different condiments you can make, some drinks. We'll do sourdough bread because certainly here in the UK, sourdough bread is becoming very, very popular. So I'll give you some tips on if that's the kind of thing you want to get into. And we'll briefly cover Koji. And then we'll finish up with some safety tips. So I know, John, you mentioned about some exploding kombucha bottles and things like that. So we'll cover some things there that'll hopefully prevent that for people moving forwards. Okay, so fermentation. There's a few different definitions of it, but basically I like to think of it as the action of changing the properties of food and drink using living organisms. So fermentation was historically used to preserve food, improve the nutrient quality, and create new flavors. So we're sort of looking at pre-industrialized food technology here, basically. So before people had fridges, they had to have ways of preserving food. Now in sort of the modern times when most people have refrigeration and things like that, we're more focused on nutrient quality and creating new flavors, although preservation is still something you can use. You know, I've got lots of things tucked away in cupboards that don't take up lots of fridge space, which is also useful. And as we mentioned before, sort of preserving large amounts of food, if you've got an allotment or something like that, it's quite useful for that. So because it's sort of a pre-industrialized process, like a pre-globalized process, lots of cultures around the world have their own histories of fermentation. So this is sort of an interaction between what sort of food is locally abundant and then things like temperature, weather. Because these were stored outside of fridges, you're kind of more at the mercy of, you know, the local temperature, the climate, the humidity, that sort of thing. So because of that, there's a huge variety of fermented foods. Pretty much every culture has some sort of fermented food as part of their diet. Maybe not now, but certainly historically. And there's some nice ways that fermentation has been described, sort of delicious rot or cold fire. So it's the idea that you're changing the properties of food in the same way that cooking happens, but you're doing it with microorganisms rather than heat or, the ways that we traditionally cook using sort of ovens and fire and things like that. So you're still creating an edible food, you're just doing it in a different way. So I just thought I'd spend a brief moment on sort of a bit of a case study, really, on the differences between sort of different areas of the globe when it comes to fermentation processes. So a good way to look at this is the difference in the brewing process, or, brewing and baking are kind of related. Certainly, a lot of the traditions that we have in Europe come from Middle Eastern processes. So this is using things like wheat and barley. Whereas in more East Asian countries, it's more based on fundamentals like rice. So the Western brewing tradition comes from these sort of Middle Eastern practices. So this is basically a chemical process. So you may have heard of malted barley or malted wheat. So this is a chemical process that turns the unfermentable sugars that yeast can't digest into simple sugars, which then will become, alcohol, or in the case of bread, it's used to raise the bread. So that's a chemical process that you can use using heat and different temperatures and humidities to get fermentable sugars. Whereas rice isn't really something that you can malt. So the production of fermentable sugar from rice has come from a mold called Koji. So we'll get into this a little bit later on, but it's a really interesting example of sort of, if you look at sort of East Asian alcohol and Western alcohol, they've both come from, one is a chemical followed by a biological process, and the other is like a two-step biological process. So it's just really interesting to look at how fermentation processes have been guided by sort of what's locally abundant and the climate and things like that. So getting into the microbes, this is a very, very high level overview. I'm not going to get too detailed on this, but we've just spoken there about yeast. So yeast produces alcohol and also carbon dioxide in the case of bread, and that inhibits certain bacteria and molds. Bacteria produce things like acids, which kill certain molds and yeasts, and then molds produce digestive enzymes and antibiotics. Some of us might be familiar with things like penicillin. So that was originally produced by a mold to protect it from, other yeasts and bacteria that were in its environment. So these sort of three groups of microorganisms are all sort of interacting in a ferment. And what we're doing is we're controlling the conditions in certain ways that we'll get into in a minute, that sort of create your fermented product, and it changes the flavor profile depending on whether it's like yeast dominated or mold dominated or something like that. So we'll go through some of the common examples. Bread is obviously yeast. Everyone's pretty familiar with that. But in sourdough, we're also using bacteria and some sort of naturally present microbes to create a slightly different flavor profile. Beer and wine is also yeast. So sort of brewing and baking kind of happened around the same time in the Middle East. People kind of argue over which came first. But again, they're both yeast derived processes. And then vinegar is, it's yeast followed by bacteria. So vinegar is created from alcohol normally. So you have to have an alcohol base in order to create vinegar. So the bacteria called acetobacter will break down the alcohol compounds. So vinegar isn't alcoholic because the bacteria have broken down the alcohol and created it's called acetic acid, the vinegary taste. Cheese and yogurt, obviously, some people are very familiar with these, and there's a huge variety of cheeses. So you've got yeast, bacteria, and molds. You've got all three in different ways, working together in different ways in different sort of cheeses and milk products. Ones that people don't think of quite so commonly as fermented foods, chocolate and olives. So these are a combination of yeast and bacteria. Olives are typically brined or had a lot of salt added, and the bacteria sort of break down some of the indigestible compounds in olives, like fresh olives off a tree, I believe, aren't actually edible. They have to go through this process to create the sort of salty olives that we know. And then chocolate is a really interesting process from the sort of raw materials before you're actually making the chocolate bar to get the cocoa. These are fermented in like big drums and turned over. They get very hot. It's really interesting if you have a little look online at the cocoa making process. It's really interesting to see the chocolate pods turn into cocoa because they look completely different. Cured meats as well. So bacteria and mold are the kind of dominant microorganisms in that, using different drying processes to extract different flavors. And then miso and soy sauce. So that's your combination of mold, yeast, and bacteria. So these all happen at slightly different stages. It's quite an involved process to produce things like misos and soy sauces. So we'll take a look at fermentation and health next. So sort of gut microbiology and understanding how people's sort of bacterial composition in their own bodies can affect health outcomes is a really, really new science. People are starting to make some really interesting discoveries, and there's a lot to read about at the moment. And because fermented foods contain sort of these bacteria, molds, and yeast, people are thinking about them in ways that they can affect our own sort of internal microbiology. And there is a lot of health claims made about fermented foods. Some of them aren't super accurate, or there's maybe a little bit more research that needs to be done, because as we've seen previously, fermented food covers a huge variety of different types of food containing different types of microorganisms. So making any claim about fermented food as a group is really kind of difficult, because it's really down to the specific, what specific food are we talking about, and that sort of thing. There's documented cases of fermented foods changing the nutritional profile of the raw ingredients. One of those examples is increased vitamin content. So because the bacteria and yeast and mold will digest some of the compounds, they create their own compounds from those initial raw ingredients. So you can get increased vitamin content, but we're coming to understand this is also very variable depending on the food that we're talking about. But there's lots of interesting research here, and you can have a little dig into the research. There's some good YouTube videos out there, and if you like reading scientific papers, there's definitely plenty of them coming out in recent years. So one thing that's also worth noting about some of the negative effects of fermentation is that some fermented foods are very high in salt, and some are also very high in acid. So if you have any dietary requirements that make you sensitive to high salt or high acid, you should maybe think carefully about bringing too much fermented food into your diet in one go. I know if I had any digestive issues for salt and acid, I definitely couldn't consume as much fermented food as I currently do. So it's definitely worth giving it some thought if you have any health conditions related to those aspects. So the equipment needed. The good thing about fermentation is it's a very sort of simple, low-tech process. You'll get a lot of companies that will sell you like fermentation kits or little bits and bobs you can use in fermentation, but a lot of stuff you can get either cheaply or for free. You can upcycle a lot of things. You can find things in charity shops. So here's a little picture of some of the things that I use when I'm fermenting. And most of this stuff has been either scavenged from previously used jars or found in charity shops. So I'd say maybe all of this maybe costs less than about £10. That crock there in the middle, they can be quite expensive to buy new, but I found that in a charity shop for about £3 or £4, and most people aren't really interested in buying things and get them quite cheap. So yeah, the things that you need, you're looking at things like glass jars. As I said before, these can be upcycled, or rubber swing top ones. Swing top bottles, you can also use homebrew bottles, but you need a special cap to those. So the swing top bottles are quite nice because the lid is built in. A muddler, so this is basically like a wooden stick that you can use to crush all your ingredients, and that helps sort of release some of the liquid and push the salt in. Muddlers can be very simple. You can use the end of a rolling pin. I've got a couple. They're very simple to get hold of. I've actually got one that's made of an old branch of a fallen tree, which I just like added some oil to protect it. And yeah, it's really simple. You can muddle with your hands if you want as well. You don't necessarily need one. A scale is probably the most expensive thing that you'll need in the whole process. Some people will provide recipes that use volumes, but I like to use a scale because it just helps you scale things up and down, if you pardon the pun. So you can do everything by weight, and it just makes it a lot easier to work with, I find. And then a muslin cloth. You can also use tea towels. Some people use clean old t-shirts. Just make sure it's well washed. And these are basically just used to strain out liquids. So if you're making things like kombucha, it's helpful to pack any of the solid ingredients and sort of filter it into the bottle. So I'll just spend a little bit of time on salt. Salt's used quite a lot in most ferments. And this was historically the way that we would preserve the food, by heavily salting it. It keeps out unwanted microorganisms and draws out liquid, and obviously adds flavor. When you're using salt in fermenting, you want to be looking for things like sea or rock salt. So you don't want any of the like table salt, because that often has iodine and things that help preserve it. But these extra ingredients can also prevent microbe growth. So it doesn't make it very good for fermenting, because it will actually kill off the microbes that you're trying to grow. So yeah, look for sea salt or rock salt. Check the ingredients and just check it's 100% sea or rock salt and there's no extra ingredients. So I like to think of salt as percentage of total ingredient weight. So this is a concept that ranges across all sort of salty ferments. So you're looking at 1.5 to 5% for like a short-term ferment. So you're looking at weeks to months, and things like fruit, vegetables, and hot sauces all use that sort of range. And then 5 to 15%, you can go higher than this in some very specific cases, but these are for like long age ferments that go on for months to years. So misos and soy sauces and things like that. So the rule with salt is generally the more salt that you're using, you're either fermenting longer or you're doing it at a warmer temperature. So that's just something to consider when you're sort of thinking about adding salt to your different vegetables and things like that. Another thing is looking at temperature and time as ingredients. So we kind of mentioned it previously when we were looking at salt just then. But because these are living cultures and they're constantly changing, the time and temperature both will have an effect on what you get out of it. So this picture here is of some lime pickle that I've currently got sat on my windowsill. This is one that you ferment quite warm. So you're actually using the sun to drive some of the processes a little bit and speed everything up. This is a very salty ferment. But, you know, I'm using things like temperature by putting it on the windowsill, letting it get the full sun, that sort of thing, as a way to sort of influence the finished product. A lot of recipes will say specific times and temperatures. They'll go into a lot of detail around things like creating sort of warm boxes or particular spaces. That's not always necessary. It is in some specific cases, but for most simple ferments, you can just, if it's a little colder, it'll take a little longer. If it's a little warmer, it'll be a little quicker. So I think the important thing to know when you're getting into fermenting food is taste it as it goes through the process. Take a little spoonful out, or, you know, if it's a drink, you can drop a straw down the side and sort of cap it and pull out a little sample. And just taste it as you go. And what one person likes might be different from what another person likes. Some people might like things quite sour. Some people might like things quite sweet. So, you know, just get to know whatever it is that you're making and understand how it goes through that process, and just make it exactly how you like it. That's basically what I do. So there's sort of three main types of ferments. There's, you know, there's a whole variety, but there's how they start is a good way to look at sort of the different types of ferments. So you've got your spontaneous ferments. So these sort of start due to natural microbes that are present on the food itself, or they come from the air, or even on your hands as you work with the food, as you're crushing them, chopping them, that sort of thing. So these are traditionally lacto ferments, a lot of these that start spontaneously. If you are getting food in, you might want to just give it like a light rinsing under the tap. You wouldn't want to be adding soap and things like that, because things that are, soap's designed to kill microbes. So you want a little bit of natural bacteria present. So if you're getting it from your allotment or something like that, then just give it a quick rinse. You don't need to scrub it or do a lot of processing. Backslopping is a technique where you take a portion of the previous batch. So you'll make your first batch, you'll package it, or put it away however you like, and then you will add some of the old batch into the new batch. So sourdough bread starters work in this way, but you can also make these spontaneously. So we'll look into that a little bit in the sourdough section. And then you've got cultured products. So these are ones where there's a defined culture of microbes. So if you think about, if you make normal bread, that you'll be adding baker's yeast. Cheeses are made in a similar way. A lot of cured meats are made in that way. Things like kombucha and koji, they all start from a defined culture rather than just letting sort of whatever's present in the environment sort of inoculate it. So we'll get started on some of the basic ferments now. So sauerkraut and kimchi, I'd say, are like a really fundamental process to understand. You can apply the principles to a wide variety of vegetables. Sauerkraut is sliced red or white cabbage. You add around 2% salt and leave it out at room temperature for around 3 to 7 days, depending on how warm it is. And then you can add things like juniper berries, caraway seeds. You can add all sorts of spices and herbs, really, and just sort of do it to your taste. And then kimchi uses sort of napa cabbage, daikon radish, and sometimes spring onion. You add more stuff to kimchi like garlic, ginger, Korean red pepper flakes. And you can add things like shrimp paste, seaweed, or miso as well. And this is a slightly more spicy ferment, but again, you can use the same principles to create a sort of spicy kimchi style ferment or a more sort of subdued sauerkraut style ferment. And you can apply this to a whole range of vegetables. So I've kind of used sauerkraut and kimchi to put forward like a basic process for sort of any vegetable that you'd like to work with. So if you've got certain things that are locally abundant, you can, run them through like a sauerkraut or kimchi process. So basically what you do is you chop your vegetables, and you can chop them fine, you can chop them thick, it doesn't really matter, it just depends on what you like. Salt by 1 to 3% of the vegetable weight. So you want to weigh all of your ingredients and then work out the percentage of that weight as salt. So I normally use 2.5%, but you can use 1 to 3 as a general guideline. And you can either use the salt directly on the ingredients, or you can add it into a liquid and create a brine. So you can do things like cucumbers in a brine rather than salting directly. And then if you are dry salting, you want to squeeze everything together, and this just helps the salt penetrate all the ingredients, pull out the liquids. And then finally, you pack these into jars, and you want to keep the vegetables pushed down under the liquid so you can get little fermentation weights. Or some people use plastic food bags filled with water to just keep everything pushed down. If you are going to use plastic bags filled with water, one thing that some people recommend is double bagging them. And also the liquid that you fill the bag with should be around the same percentage salt as whatever it is you're fermenting. So you can dissolve the salt in the water, and then that has the advantage of, if the bag does leak, you're not diluting the salt that's currently in the ferment. So this is the basic process. You allow everything to ferment for around 3 to 7 days. And again, just taste it as you go and see how it gets, see if you like it. Maybe let it go a little longer and see what that turns into. But yeah, once you've made it, you can then keep it in your fridge, and it'll last for months. So then condiments, so hot sauces and pickles. There's a variety of different ones you can make here. So these two condiments here, these are both chili based. So the green one is a green chili and lime zest, and the red one is a red chili and garlic paste, sort of like a sriracha kind of style ferment. I'll be sharing some ingredients and some recipes after the presentation, so we can focus on how to make these in that document. And yeah, it's a kind of similar process, but the only thing you're doing here is you're blending everything afterwards. So you're blending it to a paste, or if you like it a bit more chunky, like things like lime pickles, you'll traditionally use a higher salt content, but you'll use less of it in your finished ingredients. So if you're using it in a curry or something, you'll just sprinkle a little bit on top, rather than things like kimchi, where you can actually use it as a base, almost like a stir fry base. And then there's an interesting one that you can do with honey fermented garlic. So you're not adding salt there, but the honey itself is antibacterial. You create this selective environment where you can make these really nice sweet garlic cloves that have fermented, and you can also use the honey in like salad dressings and things like that. So then drinks, we've mentioned kombucha before, but you can make a whole range of different fermented drinks. So kombucha is just a simple sweet tea that you make with a SCOBY. So this is a symbiotic culture of bacteria and yeast. So what you want to do there is, a lot of people share their SCOBYs. They kind of form in layers. I don't know if you can see it very well in this photo, but those are all layers of the SCOBY, and each one will form a layer on the top, and the lower layers will drop down a little. And as it gets heavier, it will sink, and a new layer will form on top. So the good thing about SCOBYs is you can just sort of pull a layer away and give it to a friend, and then they've got a SCOBY to work with. So you do your sort of primary ferment in a jar, and then when you bottle it, you can add fruit, you can add ginger, that sort of thing for extra flavors. And another drink that I like to make quite a lot is tapachi, that's made with a spontaneous fermentation, so you don't need a SCOBY to do that. And it's a simple way to do that is just pineapple, ginger, and brown sugar. You can add in other flavors like cinnamon. You can add different fruit in as well. But yeah, because that's a spontaneous fermentation, it's a little easier to make. You don't need to wait to get a SCOBY for that. And then once you've bottled them, you just put them in the fridge. They will continue to carbonate. So if you've got exploding bottles, it's probably been left too long. You can slow this down by putting it in the fridge. So once you've bottled it, put it in the fridge, and I'd say maybe a week or two is a good amount of time to leave it. After that, you might get bottles that will go everywhere when you open them. So then sourdough bread. Most commercial bread's made using baker's yeast. So some of you who have baked before have probably seen the little sachets or whatever. But sourdough starters are made entirely from what's in the natural environment, the air, the flour, that sort of thing. I'll put a starter recipe in that document that will circulate around afterwards. But you basically just mix equal amounts of whole wheat flour and water together, and then you feed it each day with a small amount of the same water and flour mix. So what people can do, you can see here the sourdough starter. The one on the bottom is when it's just been mixed, and the one on the top is after around 24 hours. So what some people do is they'll put an elastic band around the level to see where it was before it started fermenting, and sort of the amount of expansion you get can give you a good indication of when it's ready to bake bread. So this is almost double. That's probably about as high as it'll get. Some people can create these crazy sourdough starters that will bubble up and go out the jar and that sort of thing. But as long as it around doubles, I mean, you can see all the bubbles there, that's nice and active. And then you can use that in home baking, and you can keep that going for years, or you can make a new one each time. So this one was a single one that I just made to take some quick photos of, but I've got one in my fridge that's, I don't know, maybe around 8 years old now. There's not really any benefits. People just kind of like having an old starter because it's something they can keep in the family. They can, pass down to their kids or whatever. But in terms of the benefits of having a really old starter or making a fresh one, there's not really much difference when it comes to making tasty bread. And then we'll just take a quick look at Koji. You could do a whole webinar on Koji. It's something that I've only started working with in maybe like the last year or two. And this is sort of, Koji is to sort of East Asian foods what yeast is to, I guess, like European foods, so like bread and beer. Koji is a different microbe that sort of filled that similar space in some East Asian foods. So you can buy dried Koji online. It is quite expensive. Often you're shipping it long distances from, from Japan or China or whatever. But you can also keep growing it, and you can keep a continuous culture of it at home. One of the advantages of Koji is you can dry it out and you can use it whenever you need it. So you can see the two different pictures here of Koji. You can see the one on the bottom is slightly whiter, and the one on the top is more the color of the original grain. So this was actually grown on barley, but you can do it on rice, on wheat, a variety of different cereals. So the one that's on the bottom that's really white, that's actually gone to spore. So the spores can be used to inoculate more rice or wheat or whatever, and you can keep a culture going. It's quite complicated. It's quite involved. You need sort of a cool box. This is one that you need to work with in a temperature controlled environment. So I won't go into too much detail, because you can also buy it dried. You can use it at home in that way, but it is quite fun to grow, and I've been playing around with it recently, and it's quite an interesting one to play with. And because Koji is so complex, it can break down cereals and make them sweet. But because it's a mold, as we spoke about before, it's got these digestive enzymes. It can break down protein. It can break down fats. So people are doing all sorts of really interesting stuff with it currently, using it to cure meats and do things with beans, make miso and soy sauce and things like that. So it's definitely one that I'm continuing to learn a little more about. But if you're interested in that, definitely grab some of I'll share some resources where you can learn more about these things. So yeah, we'll just look at some safety tips. So these are some just general ones. So when it comes to fermentation, we've kind of a lot of us here certainly in Europe we're used to really processed food now, industrialized food that's packaged. It has a sell-by date. You have to keep it in the fridge, that sort of thing. But it's a historical process, and it's just something that we've sort of forgotten. I know I was very uncomfortable with ferment. It didn't seem right having these sort of living foods, but they are generally quite safe if you do things properly at home. So some of the safety tips I would give: so calculate your salt in percentages using a scale, which I talked about before. It gives you more accuracy, and it just gives you a bit more control. You want to clean out your vessels well between uses. This is if you're not doing like a backslopping process. You can reuse a vessel, and whatever's growing in the vessel will actually keep the next culture going. But you want to check things like broken seals. You want to check for any cracked glass or anything like that, and just replace these out as you find them. As I said before, any of your solid ferments, you want to submerge them with either fermentation weights. You can actually use clean pebbles. Like if you go to a pebbly beach or something, you can clean up a pebble, sort of give it a good clean at home, and then just use that to weigh things down. Or you can use plastic bags filled with water. You can get quite creative. If you look online, you'll see a variety of things that people do. Another thing that people do if they're working with sauerkraut is you can actually use the end of the cabbage that would normally get discarded. You can actually use that as a weight and sort of use it to push down the rest of the shredded cabbage. So that's something I do quite often, or like a cabbage leaf to cover everything. Another thing that you want to avoid, some people talk about fermenting with oil, but it's generally not a good thing to do. Some ferments, you introduce oil at the very last step, but you don't want to cover anything in oil, or generally avoid oil if you can, because there's the stories of people getting botulism from things that are preserved in oil. You have to be really careful with these, and you need to really know what you're doing. So I'd just say avoid it if you're just starting out. You want to what's called burp your jars frequently to avoid pressure buildup. So this applies if you've got like an airtight seal, like a screw top lid or a Kilner type jar with the rubber seal around it. One thing I like to do with the Kilner jars is you can get an elastic band or a few elastic bands and tightly wrap it around the clip. And the elastic band just gives it enough give so that any air that builds up, any air pressure can just escape quite easily. But if you're not using that, you want to maybe crack them once a day just to make sure any gases is released. And yeah, about bottling drinks in glass bottles, you want to make sure you're using high quality ones. So if you're upcycling and you're getting your bottles from ones that have been pre-used before, you want to be using glass bottles that have already held fizzy drinks, because you'll know that these can stand the pressure. Some of the ones you can buy in some shops will be decorative. They're not quite as thick, and there's not really a way to know. So I would say the Kilner ones are fine, but any ones that aren't branded, you need to be a bit careful. I'd say generally avoid ones that are square bottles as well, because the pressure doesn't distribute properly and these ones can crack. Another option you can do is just bottle them in reused plastic bottles. A good way to use plastic bottles is you can feel the pressure building up in them. So you can kind of, if you like bottling in glass, I always bottle one in plastic and I kind of squeeze the bottle. And once it starts getting quite, it doesn't really resist, then you know that the pressure's probably getting to the point where you want to be drinking your glass ones and not leaving them for too much longer. So that's another way to sort of be safe when it comes to that. So yeah, I'd just like to close with a thing on sort of why bother with all this stuff. It takes ages. It can be very involved in some cases, but I really like it because it's a really interesting way to learn about food, history, and culture all at once. So you can start reading about the ways that different countries make fermentation products and things like that. So you can learn lots about ingredients. You can learn lots about the histories of the different cultures and stuff that use these ingredients. It's a really good way to reduce waste. So things that some people might throw away, you can ferment, and because it changes the quality of the food, it will soften things up. It will, make them a little bit more tasty. I know I've had some people throw away kale stems, some people throw away cauliflower leaves, that sort of thing. I use everything whenever I can, but you can ferment these things, and because they're quite woody, they'll kind of soften up, and you can use them as like a little relish on the side, and you can sort of get creative with it. It's a slow way of cooking, so it is quite involved, but because of, if everyone starts fermenting, like I've got a few friends who do different things, and we've kind of all got our own little specialties, and you kind of get to know one another, and you're like, oh, so-and-so does really good like salted lemons, or so-and-so does really good kombucha, or this guy makes really good sourdough bread or something. So you can kind of start swapping these things around and like learning a bit from others, and, it builds a nice little community around the idea of making food. A lot of the time we're looking for like quick meals and food as fuel, whereas this is like food as like community building to get a little bit sort of misty-eyed about it, I guess. And I just really enjoy it. I think it's really fun. It's really satisfying to have these ingredients that you're bringing into your kitchen that you can't really buy in shops. So yeah, it's a fun process, and I really enjoy it, and I recommend others get involved. So yeah, if anyone's got any questions, as I said, I'll be sending that recipe document around with some resources as well. So there'll be some books and some video links and stuff in there for people to check out.
Great. Okay. Can you hear me okay?
Yeah, fine.
Okay, great. So we have got a couple of questions, and I think I've got one as well. So, but I'll start with Judith. Can you explain spontaneous fermentation? Please, do you leave it open to the air, or is it triggered by microbes on fruit, etc.?
So it's kind of a mix of both. So often when you get fruit, you might see like a little bit of a coating on it. Tomatoes are a really good example. If you grow your own tomatoes at home, they have that sort of powdery coating on them, and they've got that really nice tomatoey smell that I don't think you get from sort of store-bought ones. And this is a kind of yeast that grows on the tomatoes, so a lot of the microbes are already present on the fruit or the vegetables, but then there will be things in the air that will also interact with that process. You're creating like a little community, so it's a mix of sources, really.
Great. Thanks. I've got one about sourdough. We've got a sourdough starter at home, and it is it's been in there because we were baking a lot, and since the shops have opened a little bit more, we're not doing quite so much. It's been in the fridge now for about 3 weeks or so.
Yeah.
But we haven't been feeding it in the fridge.
Yeah.
And we are actually weirdly attached to this sourdough, as you say. You kind of start to take it in as a family member, really.
Yeah.
And yeah, is it possible to revive it after that amount of time, or do you need to keep feeding it quite regularly?
Yeah, I'd say generally. So I guess as you're sort of separated, maybe, and the liquid on top's quite dark.
Yeah.
Yeah. So what I normally do when I've left mine for that long and even longer sometimes. So what I'll normally do with that is I'll weigh the jar, I'll pour off the dark liquid, and then I will add in clean, sort of fresh tap water backed up to the amount that you've just poured off. Yeah. And then I'll start feeding it from there, and I'll maybe then you can throw away most of that and start with maybe like a tablespoonful, or just what's left coating the jar, and then you can just start rebuilding that up. You can make a new one for sure, but you can totally just start just give it a lot more frequent feeds and kind of get it back up to its former glory. But they're generally pretty safe. They'll go pretty funky, but you can bring them back from the brink quite easily.
So that's like that's the sour bit, is it, on top that liquid? So does it sort of get too sour for itself? Does it sort of slowly kill itself, does it, or something? And then you can kind of revive it?
Because you've got like a mix of yeast and bacteria, it becomes a bit more bacterial dominated than yeast dominated. Yeah. So some people will let it go quite far, but what's always tricky with sourdough is getting the right balance. Sometimes it'll just taste like normally baked bread, and you kind of don't get that sour taste. And other times it won't have any rise, and it'll just be a little brick. So it's hard getting that balance. Some people will actually use that liquid to add sourness into their loaf, and they'll keep it to one side. It's not something I've played around with, but yeah, it's always a balancing act. I've been using my sourdough starter for years, and I'll still sometimes get a loaf out that's just awful. So yeah, it's a really evolving process.
Yeah, great. There's a few people just saying how brilliant the webinar's been. So thanks for that. And yeah, I found it fascinating, and it's amazing how much you've managed to condense into half an hour. I think you probably could have done one of those subjects in
definitely
in an hour or something, go one of those different types of fermentation. So yeah, I mean, I'm definitely gonna go away and ferment some stuff. And I think Judith just typed something. She's just saying that she's had to throw away a sourdough a few times. Someone else saying thanks very much. So I think that's it really, Jonathan. So
no worries.
Good luck, everybody. All the best, and enjoy the weekend.
Yeah, thanks very much, everyone.
Thanks very much. Bye.
Catch you later. Bye.